Hello everyone, you can hear me I hope quite well. My name is Tom. I'm currently working at the one side of DHL Data AI. On the other side I work at mloda. But actually here this is a bit independent from both. I have figured that we had in the last months on a lot of other meetups, conferences and so on, the topics actually where do we now go in the at the moment situation. So on the one side, you have all kinds of data products, which is data warehouses, data lakehouses. And I think these I would maybe call the core discipline. On the other side, we have all the other ones, meaning data apps, feature stores, streaming platforms. And I think a lot of the current tools, and specifically data science, are using actually the latter ones. And therefore, I think it's interesting to see in the moment market to talk about those. Right? Because the core, it will grow in the future, but there's even a larger space in the other ones. So essentially what I mean with this, you have BI tools, you have this always the data in the last stage. Basically, often this is for the management. Then you have the feature stores where you have different stages of the data because the data for classic ML often needs to be in a different state than BI tools. Then you have data apps streaming ML pipelines. And at the end, the newest part is, however one wants to call it, right? Here I use RAG, powered chatbot or AI agent, but I think the name is not clear at the moment, that this is the newest one. At the end of the day, all of them have something aligned that without data engineering, they don't work, right? The RAGs are just expensive autocompletes, but the others don't have either governance, have audit problems, management cannot be sure about the data, and the data scientists cannot do their experiments. At the end, what that means, that there's no money for data engineering, because if you cannot justify it, you have a problem there. And the second thing is, I think we see something what we've seen already in 2018. So at that time, the new job title came up, the junior data scientist or data scientist. There, it was quite common in small companies to create the dynamic pricing pipelines. At the end of the day, what it means that people like me at that time started to build data pipelines and BI tools, because at the end of the day, there was not there. The structured data was usually messy. It was in engineered software databases. And this is what we're seeing. I think, this is a hypothesis, I might be wrong. I think again, with the AI engineer title, sometimes it's data scientist. But at the end of the day in organizations, and this I've done the whole year long, build a chatbot, agents, and we try to add organizational data into it. So unstructured data. At the end of the day, what we're building, these so-called RAG pipelines, whatever this really means. And what we see now, what AI products work, is usually those which have like 1, 2 data pipelines. But if it gets more, it's not really working. And I see the same with dynamic pricing. I think there's a bit of repetition that the data follows a bit the user needs, and this has to change, I think. And it's also an opportunity for the next years, I think, to come. What is the learning there? Right? The organizations had the structured data already from the software engineers in the databases. They have already the unstructured data somewhere stored, but that doesn't mean it's usable. And this is the opportunity actually for everyone to use. But this is something what we need to leverage, right? And this is also something which the organization has to learn. And there we need to teach also the organization. So this is also on our side to do. Actually, there is the later time when the organizations learned that you need to have BI and ETL tools there. But the next step is not to run to machine learning models, but rather to do if-else logic, right? So the business at that time was often quite happy about it. Of course, not for every business, but if you make money, more money than before, because the dynamic pricing now works a bit, and yeah, the tools are easy, actually the business likes it. It's easy making money. On the other side, I experienced this also For the work-life balance, fantastic. But I also feel that it's not really challenging, and actually it also makes replaceable. So, and that time I realized this was, I've seen it multiple times at that time, and I experienced myself, that if you wanted to do analytics, machine learning, and so on, you ended up on the data engineering side. Why not directly apply as a data engineer for machine learning at that time? And this is maybe something for all those who are maybe trying to tackle the data engineer. This is for those who are looking for the market. Maybe you try to apply for those jobs specifically. Now we come a bit more closer to the topic, meaning what does ML need? And I learned quite fast that the core data engineering skills have to be a bit adopted for machine learning. So you have topics like data drift, recency, time travel, and that you use different technologies. What do I mean with that? Well, the data scientists expect that the data contains information that if you train a model with data in the summer, that somehow you have also data in the winter in there. Of course, that's not possible. So you need to provide all the data at the state of that time. So you need to make sure that if you have the data complete for both sides. This is important for AI and ML, actually. The second one is the recency. What do I mean with recency? Imagine that if I would be a model which is trained in 2010, and if I would have the information that Bitcoin would be so good, I actually would just predict buy Bitcoin. Of course, I didn't know it at that time, meaning that I would just be a cheater essentially at that time, and the model would be perfect. Yeah, it would be perfect for the experimentation, evaluation, but in production it would horribly fail. And this is something you need to solve. This is also AI and ML. The next thing, time travel. This is at the moment not AI. Why? Because sorry, I just skipped. So what I just explained was time travel. Sorry, I'm really bad. So basically, sorry, my bad. So in time travel with the Bitcoin, if you create a model, then you store the information at that time. And if you add future information, that's not possible. Meaning that it's currently only machine learning. In AI, now you get small language models, and in some organizations, you start with neural nets for recommenders. But I think this is more for larger organizations, it's more upcoming. But for recency, this is valid for both. The latest example, I mean, I don't want to talk about politics, but was, for example, that ChatGPT 4.0 to the middle of this year still said that Biden was president, right? And it was just fixed by adding the search functionality. So basically, the model itself had the issue of recency, and they had to add a second tool to fix it. So in this way, you can deal with it. Then you have, of course, the other thing, which is quite important for machine learning, is that you have experiments, you have production, and you have real-time serving, and all work with different principles, and all have different data pipelines. There's some solutions possible. You can build something custom, you have feature stores, data apps, you have event-based driven training pipelines, and I think this is a bit core to the presentation, so let's go a bit deeper into it. But the feature store was in 2020, 2021 quite a promise, and it's existing, but I think it's not as popular as it, in my opinion, could be. And here I have a question for you all, because I want to understand better who you are for the future slides. I have some questions. Can you please raise your arm if you have used the feature store, but you hate it? Is that 1, 2? Okay, let's go over then. Have you used the feature store, but you liked it? Is this also 1, 2, okay, 3? So more than hate. I'm usually on the hate side. Then the next question, what is a feature store? Okay, that's the clear majority. Okay, what is the feature? Okay, good. And then, yes, you you have heard of feature store, but actually don't mind about a feature store. Okay, it's one person. Okay, sorry then for you. Then I don't know, drink something meanwhile. Okay, so actually this was the majority, was about feature store then. So the feature store is the central system actually, which purpose is to align the different phases, right? You have the experiment phase, which I earlier said, you have the batch training phase, and you have the real-time experimentation phase. And now you have the technologies, but also the amounts of data is different, meaning you use different technologies. How do you keep it in sync? How do you solve the recency topic? And for this, there is the feature store. The feature store has some good things, right? You can make features reusable between projects and teams. So in theory, it should make it cheaper. Also, you have consistency because you can invest more time into, for example, checking the data. On the other hand, what you now do is you add an object into the whole infrastructure, which basically cleans or takes clean data, changes it, and creates new clean data, meaning that this is quite significant, and one should really think about it if this is really good or not. A custom pipeline, maybe, which with a Redis database is not the better solution. The costs are quite significant. You have licensing costs often, because a lot of them are actually not open source. Open source, for example, is Feast. I think is one of the classics there. You have the feature form, which is also a classic. You have mloda, which is rather new, but is another thing. I think the most important next to Feast is Tecton. This was in the latest news, I believe, because it was bought off by Databricks, because of I would assume that they also see the issue what their own feature stores had. But at the end of the day, we have an issue with all of them. We have a problem. They struggle because you connect to a lot of different infrastructure in an organization. That means you have governance issues, you have also knowledge issues, and the next thing, not a lot of people know about these tools. Even if you adopt it in a team, how do you iterate over it? The next team, that's a problem. The next team doesn't have the skills. Then you have, there's a thesis by me, might not be right, but I would say it has a similar problem like data catalogs have. If you have a very small team, then a data catalog, how much value does it have? But if you are too big and you have 10 data catalogs in the company, then the dream of the data catalog, then all your data, metadata, is a single source of truth, is still described, is also gone. The next thing is, feature stores are just fixing one part of the issue. And if you have other bottlenecks, then this really does not matter at the end of the day. Meaning, if you have downstream evaluation issues, and this is one of the most costly part, then does it really create business value? What I really like about feature stores is they have some implicit structure between data producers and data users. So there is a clear boundary, what a lot of other data products or data close products have or don't have, and this one has it. Meaning, that's probably good to have. But here we also see directly one problem. Who are the data producers in the feature stores? Sometimes it's data engineers, sometimes some ML ops, sometimes data scientists, sometimes software engineers. I've seen it all. And that's, of course, I think it's quite open. On the other hand, there's the data app. I think it's one of the underrated things where no one talks about it, but actually every organization has it. There also have the thesis that chatbots, especially modern ones, from this year, maybe end of last year, are also data apps. The first ones, of course not. They were just requests to LLMs. They didn't do, but the newest chatbots, usually they request data from query, from databases, and so on. And that's why they're essentially data apps. What's the advantage, and that's why it's a good thing to have, is everyone knows it, means great adoption, and they're quite deterministic, meaning it's rather easy to engineer, and it's quite nice to have. But this is a good one, of course. What do I show? I show something what I really dread in my life. is if you have some kind of sequences of training, meaning you have batch training, meaning you have first a batch training process, then you have a training, another training, and you have batch data process, another training. This is something I really dread. I have there multiple projects in my past. One, for example, was a fraud detection pipeline. So classic fraud detection model, so you have a transaction, you say it's fraud or it's non-fraud, but you can also formulate it in a way, hey, does the model know more or less what it is, or is it a strange one? And if it's a strange one, give it to a human who actively checks it. And at the end of the day, what that means, that this human then labels it also as fraud, non-fraud, and goes back into the model. What you now create is a non-deterministic result. Now you change the second, the human result, and go back into the new model. Does it mean really you get value? Or did other training data impact it? Or was it this transaction? What is if you change the screeners and maybe they change the functionality? This is an easy example. But there is sometimes process with 8, 9 steps, what I've seen, and then it gets really hard. Also observability then gets hard. And how do you migrate such a thing? And this is something I believe as a data scientist, you want actually deterministic results. This is what you want, and this is not what this is. So be careful if you're getting in such a product. I think it's necessary to have these. There are use cases and very valid use cases, but try to minimize the determinism. And there I just want to warning, because I've read this, that people really think it's cool to create next to non-deterministic LLMs to add non-deterministic streaming. I don't mean the Kafka or streaming pipelines which go as an event bus through a company. They're deterministic, or I hope they're deterministic. That's their purpose. But if you do it, for example, in an agent system, which is very complex, and then you start streaming around between agents which are not deterministic, that's very difficult, at least challenging. Let's go a bit more into the hype topics. And there I have actually a question, because I want to understand even more the audience here. Who should be the owner of a rack? Is it the data engineer? Can you please lift your arms, maybe? Who you think it should be the data engineer? Okay, it's 2 people, 3, 4, okay. The data scientist, who should be? It should be the owner of the rack. Data scientist, anyone? 1, 2, 3, 4, 5, 6. So it gets more. So it's a bit more. Software engineer, AI engineer. So 1, 2, 3, 4, 5, 6, 7. Platform engineer. So essentially we had a split between 3 positions, actually, quite similar. So actually I think it's not clear at the moment who's the owner. For me also not. But this is to be aware if you're going to an organization that actually no one knows who should own this, who's responsible, and who should do it. This is also an opportunity to realize that maybe one company will reject your CV, another company will take you because they have just different expectations. And this is at the moment, as it was with the data scientist, it's now with racks, AI engineer, and so on. So really, this is my thesis. We repeat it. So now a bit back to the graphic at the start. Here I have some things. I think, what are the easy things? What is typical data engineer? 100%, it's this one, right? You put the data into a database somewhere. That's clearly 100% data engineer, I would argue. Then you have the rack itself, the rack logic in the database. There I have already, the governance there is, I would say, data engineers, maybe database admin, if you go a bit back in time. But there you have also algorithms. The simpler ones, I would rather, this is my opinion, put to the data engineer. But what about the complex ones? Is this a data scientist now, or still the data engineer? What about the data management? This one, between Chatbox and rack. Who is this? I think data management is typically, with data catalogs, it's a data engineer one. Then the data app, the front end, of course, is not the data engineer. Back end is software engineer, but also data engineer. I think usually they're quite easy and everyone can do it. So it might be it. And then I want to highlight something about BI tools, because I got asked there in another project, or actually 3 or 4, they proposed BI tools for analytics. And they have one issue, and this is this. if you go for racks, you have these issues. How do you solve them with BI tools? That's solvable, but actually quite expensive. Data scientists usually use notebooks for this, Jupyter notebooks. And now, if you want to be a bit better in engineering, maybe look into, if you have heard the term, Merino notebooks. Basically, you can have notebooks as code. Look at that, because then you can really do analytics by querying itself the data, and with this, you can solve these questions. That means we have some learnings, my opinion. Now, there's still a gap between data engineering and data science. Weirdly, it's the same gap between what ML has and AI. Then we get more data engineering products in general, and we will have more specialization. Meaning, is the data engineer actually still the right term, or should we have there something else? Then I have here also a belief that a lot of data scientists are either coming from software engineering or are coming from STEM. And that means that they teach themselves a lot of skills, but often it's not the data-driven recency time travel. And I've seen a lot of projects struggle with that. And I think these concepts are not the heart, and most of you, I think, all know delta tables and so on. So just apply them there and be the one who helps them, because it's quite hard to learn multiple topics. They depend more on you, so leverage in this organization. Then, if you have non-deterministic processes, make them aware. And this, I mean, not specific to data scientists, also to business, especially to agents, because this is a risk, and this can be also a problem for you, right? And I think you can handle this all. This is possible. The tools are there, but only if you realize what is not deterministic. Yeah, and this is the last slide. I have the thesis that data engineering the first time together with ML is failed stories from both sides. But I think now we have a second chance, and I think it's really quietly forming. So you saw in the last years that Databricks, Snowflake really exploded. They doubled their headcount, and if this is a bit the stock market, actually their numbers are really healthy compared to the AI companies. So the revenue to stock and so on is quite good, I would say. But this is only, of course, the public ones. You have others, products which I would have loved to have in 2020, like DBT, but also DLT, and also projects which are now rather in the MVP stage, like mloda, is a project which I work on with others, which try to solve the area between clean data and the models. But there are also others, and I think it's quite curious to see what ideas will prevail there. Right? Thank you very much.